I'd say a case of soda, 24 cans. How many cans in a 30 pack? There you go. And a gross of pencils. Who thinks of these things? Just happened to be 177 pencils. And you guys got it? Yeah, really?
No.
Gross of pencils? Yeah. But what we're using is something known as Avogadro's number. Avogadro's number is some outrageously large number. And what it is, it's 6.02 times 10 to the 23rd. And they say if, where I read this, I think it was another chemistry book, they said if you line up pennies, you can line up 6.02 times 10 to the 23rd pennies and go up to the sun and back. That's a lot. If you had 6.02 times 10 to the 23rd pennies, would you be here right now?
Nope.
No, you probably own your own country, wouldn't you? Right? So Avogadro's number, there he is, an Italian physicist, Amadeo Avogadro, or the students call him avocado. So Avogadro's number. So 1 mole of an element. If I said, hey, how many atoms, ions, molecules in 1 mole of sodium? 6.02 times 10 to the 23rd. How many atoms, ions, molecules in 1 mole of carbon? 6.02 times 10 to the 23rd. How about for sodium? 6.02 times 10 to the 23rd. So, number of particles in 1 mole is going to be 6.02 times 10 to the 23rd. That's pretty easy to figure out. Now, the rest of the chapter, or this section actually, they had you calculating, well, if I had 2 moles, how many atoms, ion, molecules would it be? And they'd have you multiply by 2, etc., which we won't go there because it kind of caused a lot of extra stress when students were multiplying and dividing with numbers with exponents. Somehow I just didn't feel a good learning connection there. So, finish that part, didn't we? That was easy enough. Now, you guys have a periodic table on you. Yep, dig out that periodic chart if you would. And in that periodic chart, we're going to talk about something known as molar mass. Here's molar mass. Here, so molar mass, upon heat in grams, that equals the atomic mass. Look up sodium in your chart. Find sodium down now. Look at the bottom number in sodium on your chart. It says 22.9, doesn't it? Don't call it 23. What we're going to do is we're going to round off. So if I asked you, hey, if I have 1 mole of sodium, how many grams does it weigh? Now, you look up in your chart. Right there, sodium, right there. It weighs 22.9. Let's round it off. Round it off to 23. So it weighs 23 what? 23 grams. All right, look up carbon in your chart. Got carbon? What's the number underneath carbon? Round it off the whole number.
12.
12. So if I asked you, hey, how many grams in 1 mole of carbon? What's 1 mole of carbon weigh?
12 grams.
12 grams. Look up magnesium in your chart. That's why I had you memorize just the basic elements. Magnesium, what does 1 mole of magnesium weigh?
24 grams.
Right, you look at the weight, look at the number under it, and just put grams. But I want you to round that number to a whole number if you would. That's what you're talking about, something known as molar mass. So the molar mass, 1 mole of an element, the atomic mass just expressed in grams. And look at that, you can use it as a conversion factor. 1 mole of carbon is 12 grams of carbon, and as you guys know, you can flip-flop them, can't you? And I normally give out a practice quiz that what I'll do is I'll copy that off and get it to you, next class. Practice quiz on this.